our first premise today is this teacher spending some dough on calculators and measuring tapes. She made an order. She bought 20 calculators, 10 measuring tapes. It cost her $495.
Oh my God.
Yeah, it's pricey. Then she was like, shoot, I'm short. I need to buy more. So she bought 8 more calculators and another measuring tape and paid $178.50. What does this represent? So what does each equation represent? Are we good with the first one being the first purchase, the second one being the second purchase? And when she made this purchase, I want to point out, all the calculators are the same price. All of the measuring tapes are the same price.
About tax.
It's all included. It's a percentage. It's good. Don't worry about tax. If we're solving the system, what are we looking for? Talk with your table partner, please. If we're solving the system, what are we looking for? All right, so what's the answer to this mean? What would the answer to this mean, Raymond? The price of everything. So the price of calculators and the price of...
It means... Oh, wait, yeah.
Okay, so next, you don't need to write this down yet, but let's try doing the Diego method from yesterday, okay? So we're going to add these together.
Why would you add them?
And we get 28C plus 11M equals 673.50. All right, so I got this new equation. Is this new equation true or not true?
True.
It's true. How many answers satisfy the number of calculators and the number of measuring tapes in this new one? There's 2 variables. How many answers could there be? Infinite theoretically. Okay? Infinite theoretically. So, Diego method currently, does it help us solve this?
Is it subtract them?
Okay, let's try that. Elliot says let's subtract him. I'm down.
Calculator really costs that much.
So 12C plus 9M equals 317.50. All right. I have 2 variables. How many answers? Infinite. So if I want a solution, how many variables do I need to leave myself with to get one variable? So we need to now look for something to cancel. So I'm looking at calculators and I'm looking at measuring tapes. And I want one to cancel. Which? Oh, Bob. Bob's saying I can make an equivalent equation by multiplying both sides by the same number. Okay. So we can mess with one of these to make something cancel. Do you think it's going to be easier to get 8 to be 20 or 1 to be 10?
1 to be 10.
Let's do it. And I'm going to show you what I'm going to choose to do. There's 2 methods you could do here, kind of. You could multiply by 10 and then subtract, or multiply by negative 10 and add. I'm choosing to multiply by negative 10. That's just how I roll. I like it. Watch. I'll show you why. Okay, well, let's look at this and see if it's more complicated.
Negative 1,700.
So if I multiply everything by 10, negative 10, and I like to put one simple line through that so I can still see it, but I'm not using it on an accident. So is my new equation true?
Yes, you have.
If I buy 10 times the calculators and 10 times the measuring tapes, I'm paying 10 times the money?
Yeah, and then you
Okay, so now I can add these together. Yeah, right. So again, you could multiply by negative 10 or positive 10, but then what do you need to do instead of add? Subtract, which is still Diego method. So when I add these together, I get negative 60C equals, I'm going to try it in my head. 0, 7, 2, 1. Is that right? Yeah, there is a negative. Okay, I'm going to the calculator. Nobody's got a calculator ready to do that subtraction for me? 1785 minus 495.
Wait, hold on. So
Oh, man. I'm going to the calculator.
What if we just round it up to 5?
Man, I was off.
Just 500 plus.
Okay, so stay with me. Stay with me. So now I have how many variables?
1.
If I have one variable, how many answers are there to that?
1.
So I'm going to divide everything by negative 60. And that means the calculator cost $21.50.
How do you know that?
I did it last hour. Okay. So, I did mental math. I could mental math that pretty well from this division. So, a calculator is $21.50. If only there was a way I could now figure out how much a measuring tape costs. Oh!
Yep, you're right. It is $21.50.
I'm going to go right there.
Wait, how?
It's $21.50.
There's the measuring tape. Okay? 8 times 21.50 is 168 plus 4, 172. I'm going to subtract everything by 172. And that means the measuring tape is $6.50. The solution to this system is the price per calculator and price per measuring tape. That works in which of the two lines? Both lines. Actually, all three lines, right? We made like that new third line when we added everything else. It'd work on that too. Okay?
What do you mean the third?
Bob asked a good question. He said, what do you mean a third line? Bob, remember when we added them together and nothing canceled?
Yeah.
This ordered pair would also work in that line. Because that line is the totals of all calculators, all measuring tapes, and all totals. Equivalent equations, yeah. They're all true stuff. With your partner, you're going to work on these 4 systems to get answers. Again, reminder, a system is 2 lines. And what are you finding? Yeah. Well, usually.
I already solved it.
You're finding where they cross, like Bob said. And what's true about that point? Which line does it work on? Both. Let's go. So let's get after it. As I'm looking at this first one, I'm looking for something to cancel because I want one variable, because one variable has one answer. I see that the 2x and negative 2x cancel if I add, which means that 7y equals 21. Is everybody good with where I'm at here? And that means that y has to equal 3. That's not my answer, right, Elliot? My answer has to be what?
An ordered pair.
Thanks. You sound a lot like Micah.
Sorry.
Okay. An ordered pair. So if I know y, I got to find x. I can substitute y into either equation. And then, once I substitute it in, how many variables do I have? 1, meaning one answer. Subtract 9 from both sides. 2x is negative 2. So x has to be negative 1, which means my answer is negative 1, 3. We're going to check it out, though. Negative 1, 3 is the ordered pair that should work in which of the lines? Both. So negative 1 here gives me negative 2. 3 here gives me 9. Negative 2 and 9. Is it 7? Check. Put a negative 1 in here, I get 2. 3 in here, I get 12. 2 and 12, is it 14? Check. We're all good. It worked. Thank goodness, man. I'd look really silly if it didn't, huh? All right. Second one. I'm looking for something to cancel. Does anything cancel?
Yes.
3y and negative 3y look like they might cancel. So I'm going to add these together. 5x is 10. Which means x is 2.
Well, yeah, but then x equals, or y equals 0.
Well, let's see. Let's put 2 in there. 2 times 2 plus 3y is 7. Subtract 4. 3y is 3. So y is 1.
Of course, so I was right the first time.
Awesome. Let's make sure. Let's make sure. I put 2 here, I have 4. 4 plus 3 is a 7?
Yes.
Put 2 here, I have 6. 6 minus 3 is 3? Good. That ordered pair satisfies both lines, which means it's the point that they cross. Next one, I can't add. So what am I looking to get to cancel?
Subtract.
I'm going to subtract or multiply everything in one of them by negative 1. Same thing. I'm going to subtract this time. So if I subtract 3y minus 4y is negative y, 5 minus 9 is negative 4, which means y is 4. Once I know what y is, I can put it in and get x. Subtract 12. Bob knows that it's negative 7. He already told me. Divide by 2. So x is negative 7 halves, which means where they cross is negative 7 halves, 4.
Or negative 3.5.
Negative 7 halves is negative 3 plus. Okay. Now, did you notice that the last one was quite a bit different?
Yeah.
I can't add, I can't subtract currently. But
All of them are going to be like that.
we are the boss of equations, and we can get an equivalent equation that will work. So we can get x to cancel or y to cancel. X is calling my name.
Yeah, if you multiply everything by 3.
I thought about doing something crazy and dividing the second one by 3. But let's multiply everything in the top by. And I'm going to get a little crazy. Instead of multiplying by 3, I'm going to choose to multiply by negative 3. If you multiply by 3 and subtract it, you're still good. Watch why I'm choosing this, though. I just like to be in addition mode. It's the same, though. If you subtract 6x and subtract 9y and subtract 48, it's the same thing as adding the negative. I just have a personal preference to that, the adding. Okay? Which the x's cancel. I have negative 14y and I have negative 28. So that means that y has to equal what?
2.
2. Once I know that y is 2, it can go in any equation because where these cross, x and y are always the same. I'm going to go in this equation just because it looks easiest to me. You'll get the same answer no matter which equation you put it into. And that means that x has to be 5. The place these two lines cross is 5, 2. Bob, what'd you get?
I got, let me see. 3.57.
Okay, well, maybe I messed up, Bob.
Yeah.
Let's check it out. 5 and...
Mr. Mack, you did not mess up. I think I messed up.
Let's check out 5, 2. 5 is 10. 2 is 6. 10 and 6, 16. Okay. I've got 30 minus 10 is 20. Do you see how we can always check an answer?
Yeah.
Now, if you had like 10 of these on homework, it would be a lot of work to check answers. I'm not saying you shouldn't do it. But, like on a test where the stakes are high and your answer needs to be this point that works, better make sure it works, right? Because otherwise, if it doesn't, you're guaranteed wrong. Okay? Cool. I don't think we need the cool down right now because we practiced these. I just want to look at this. What would I add? Would I subtract? Would I multiply? What would I do here? This one's ready to go. All right, just add. Awesome. I'm going to hand out the homework.